Welcome to EDU World Space.
We're asked to solve the previous problem, but in this case, just assuming that the weight and a lot of a lot of the variables are well, basically everything is unknown or is a parameter. So again, we're gonna leave the length of the ladder as L, the distance up the ladder the person is standing as D, their mass as M, and so then we can solve this. And again, let me label these F A Y, F B Y, M G. So we again know that the cosine of this angle here, which is again the angle with the horizontal, is 1/4 just because of the geometry here. Because we know this is L over 2. So we're given this length here. I should maybe put that in there so that makes it clear. We're over 2. So that means that we know this. So again, force balance in the vertical direction, moment balance about point A here. And we can see that FBY is mgd divided by 2L. And then plugging that into here, we get FAY is mg times, well, this is basically 1 minus d over 2L. So obviously 1 minus this, or mg minus this. So that these two things add up to the weight of the person. And now I'm going again, drawing a free body diagram of one leg here of the ladder. Taking moments about this point, we can figure out that T is given by this expression in terms of FBY, and we can plug that into here. And so things become, this becomes a 1 over tangent of theta. And then we know that given this, we can figure out what the tangent of theta is, and that winds up being square root of 15. So we have 2 times FBY over the square root of 15, and FBY is here. So we wind up with the tension, the force in this member here is mg times d divided by the square root of 15 divided by the length. So some of these things that we should kind of look at is, we can see that obviously as the person's mass goes up, this goes up, and so does this. As they get higher and higher on the ladder, this goes up, and this goes down. And we can see that when D equals L, we have mg over 2 here, and we have mg over 2 here. So when the person is at the top, these are equal, which makes sense. Again, we can see here that as they get higher and higher, this thing grows. And when they reach L, then this cancels out, and we just have mg over 15. And so when D is 0, you can see that this is 0 and this is 0. And let's see here. If D is 0, then, well, if D is 0, they're basically standing at this point in the bottom rung of the ladder. So F is carrying their entire weight, which makes sense. So then we can look at the reaction forces here. And again, this is just T. And this one here is just minus FBY. And so we can, again, look at the same things here to make sure that these things make sense. So as D goes to 0, these things both go to 0, which makes sense because basically we just have a point load. All the loads are acting at this point. So there's no reaction here, no reaction here. Let's see here. Yeah, and then there's no force in this member. So that makes good sense.